Hello there, welcome to this video. Here in this video we will try to understand how to create library objects in nanoCAD Mechanica using Make Wizard. First of all, we will see why to create library objects. As you can see in the library in nanoCAD Mechanica, you can create different types of objects library, parametric objects library. For instance, if we go to any of these objects, for instance, I'll go to fasteners and you can find any one of these fasteners. So here you can see the fasteners in reality, and then you can go for 2D drafting. So once you insert the objects, so you have different available size. For instance, if you want to make the thread diameter 16 and the corresponding part length will be available for you to choose in the assembly, right? So this is how you create objects in nanoCAD Mechanica. And you have other options like you can create different views, different orthogonal views for that specific objects. So you can create like this and like this. I'll go to this view, the top view, and some other different calculations. You can do it from the dialog box. If some company is having their equipments and they want to add those equipments or the objects in the library like this. So I have this specific components. So this is one component, this is one end products, right? So this is some products that has been added in the library. So you can hover between different size and different parameters and different orthogonal views. So it reduces huge time. If you are a manufacturing industry and you create different mechanical components, you can make a library instead of drafting each and every time or updating CAD drawing, because there's a chances of adding errors always. But if you use this nanoCAD Mechanica Make Wizard functions to create library objects, custom objects, it will give you very precise drafting within no time. So as you can see, I have one components, one end products that I can use in the design. If you have design data, new design data in hand for this similar category, you don't need to draft anything. You should go to open with Scriptmaster options, and here you should go to table and you should find this table here. So now as you can see, this is number of type of motors and this is number of poles, right? So here if you have design data in hand, you can add easily any number of sub products. So you just need to give this informations, type of motors and the pole numbers and the corresponding informations, and based on these informations one objects will form automatically. You can choose that specific category from the options available from the properties dialog box, right? So this is quite handy. I mean, it records all the daily tasks to create some of the precise 2D drafting drawing for manufacturing. So we will find in this video series how we can create some of the simple to complex objects, some of the parts to complex assemblies here in nanoCAD Mechanica using Make Wizard. So all of this will be in 2D. You will not get the 3D components here, but you can create the 2D. This is okay for the manufacturing industry who wants to use this drawing as a soft drawing, and these are very specific. You can create your product catalog, so there will be no mistakes at all. Rather manual drafting, you can always use this smart tool to create the library. So now let's start building some of the components. As I said that we will go from simplest to the complex objects. Initially, we will see the concepts of building any objects and the process how we create objects in nanoCAD Mechanica using Make Wizard. Right? First of all, you need to create some of the directory. You can right click on any directory, or you can right click here and you can add folder. So in my case, I'm going to save all of my components that I here in this directory, and I have a directory with my name. So you can create your own directory using your name or company name, and you can maintain the entire hierarchy, and you can put the objects on the right directory so that you can in fact the entire organizations can find those objects from from the hierarchy easily. So these are some of the benefits people can get, and at the same time, these informations can be import the whole template, the whole directory can be export and can be import to any of the local installations of nanoCAD Mechanica. You can, if you don't really want to export the entire directory, you can do it for a single objects. For instance, if you want to export only one hex head bolt, so you can do it from here. You just click on the objects and you will get the export option. One MCD file will be created that can be shared over pen drive or over web, and the people who wants to import that, they can import that specific components on their local system to use with nanoCAD Mechanica. In organizations where many people will be working, they don't need to worry about anything because nanoCAD Mechanica will follow one single server-based database, this one library. So they can put that database somewhere like this on the roaming folder, and the entire organization can be access that specific path, and they can follow all the objects. They can take benefit of having all the custom objects. I mean it has all more than 4,000 standard parts already included in nanoCAD Mechanica. But if you create your own library parts, that will be added, and people can also use those added parts. So without further ado, let's start how we can create objects. Initially, we will start with simple objects like one rectangle. Before I, go into the development, I should tell you something about the way we handle geometrical primitives in CAD system. So now I have the rectangles. These opposite lines are in parallel. These angles are 90-degree, as we know from the properties of rectangle. But you can always change the shape if it is a geometrical primitives. But if you use some relations, that parametric functions in nanoCAD Mechanica to make this rectangular properties intact, so you can change the area, but the rectangular properties will never end. So that you can do using the parametric tools. But if you really want to create some of the objects, some of the part or assemblies, super flexible, that will allow you to create any sort of drafting to represent any objects or any part or any assemblies, then you need to create the library parts, right? And here for this basic components, we can say that there will be two different type. There will be two different variables. One is length and one is width. So these two variables will provide us the entire rectangle. So our intention will be to track the length and width instead of objects. So anytime we will use the dialog box to ask the value of the length and width from the user, that will be added in the backend of nanoCAD Mechanica to form the rectangle. So this is how it works, and let's see how we can do it in nanoCAD Mechanica. Okay, so let's give some annotation to this rectangle. First of all, we'll go to this and we'll say this is dimensions of this line. So this is my basic entry for now, and now you can see it has 346 point something unit length. So we say it is L, right? So this is how we will have to define. So in a complex objects or in a simple objects, we will have to convert all the dimensions, all the variable dimensions. For that, the objects can deform, we'll have to replace those dimensions in terms of variables, and we will have to define relations in between those variables, right? So likewise, I will say this is not 200, close to 200, so we'll make it something W. So now I'll say okay. So now I have two variables, and I know this object is need only two variables to reform. So now to create objects, so our suggestions will be you to follow the instruction initially as similar as we're doing here. So once you are aware of most of the features of Make Wizard, then you can take decision your own, and you can make you know use of most of the functions of Make Wizard to create even complex objects as per your needs. But initially, our suggestions will be you to follow the instruction only to create the simple objects, and then you will find other options and other more complex objects. And the instruction you can find here itself in the Make Wizard. So that need practice. So this is the last objects we were edited, so I don't need this anymore. I would like to create new one, so I'll click on new objects. It will be allow me to create new objects, and here I need to choose the directory, so where I want to save the file or the created objects library. So as I said that I would like to save all the components here in this directory, and I would say this is the component name, and these are vital. You are working in an industry where they have their catalogs, and they are habituated to call that specific objects by the name. So you should use the same name to identify the objects properly. So here in this case, I will use some arbitrary name in this specific part of the video. When we find more videos where we will be creating some of the complex and legitimate objects, so we will be using some of the legitimate names over there. And then I will not write anything in the comment, and then I'll go to create empty objects. I'll choose this. I'll not choose some of the prototypes. I'll choose only the empty, and I don't need anything to choose from here because I don't really want to get help from any other templates, any other objects. This is suggested for the new user. They should choose default template for now, and later on when they will have some of the good informations, they can explore more, and they can use the functions to get more benefit out of this Make Wizard, nanoCAD Make Wizard. So let's start with default templates. So I'll click on that, and that's all. And now you are all ready to set all the tricks to make these things flexible and super intelligent in 2D. So you should follow the instruction. I mean, as we are doing exactly the same for now. So we'll click on implementation. So now we'll click, in fact, we'll right click on implementation, and then we will choose add implementation. So we'll keep the name implementation 1. That's all okay. We can make it 1, 2, 3, 4, no problem. So this is my implementations, or you can obviously you can name it something like whatever you want. You can name it something here. You can name it. You can rename the objects. You can say something top view or as per the component name, legitimate name. But for now, I'm keeping implementation 1, and then I will see these options are active now. So this is the entire projection system, and this is for hidden view to represent the hidden view, and this is for simplified view, less than the orthogonal views, and you have sectional views, and you have the dimensional views, right? So different type of views can be created, but you should remember only you will have to create the view once. So once you record those creation inside nanoCAD Mechanica, that will be integral part of nanoCAD Mechanica for life. So you can use that over and over. You don't need to draft anymore because you are recording those views. So any views you want to record, you will have to draw initially to get that view recorded in nanoCAD Mechanica. So as you can see, I created one view, and I can hover between different view. I can tell nanoCAD Mechanica which one is what. So maybe here I can say this is my front view. Maybe not, I can say this is my top view. So I'll say this is my top view, and I will right click on it in the implementation, and now I will have different options. Strictly you should follow parametric recognize view, this one, because I don't really want to create the non-parametric objects now. If you are creating non-parametric objects, you don't need any skill, anything. You just go and just recognize, name it, and use it. That's all. But here we are creating super parametric objects to reduce the drafting time. So we will be using this parametric recognize view, and then you should remember, you should select like this. The whole view, including the dimension, should be inside the selection box. So that's all. So now if I hit enter, now it says that select the insertion point. I will select this insertion point and I'll say okay, right? So this view, I should say this view is now identified, right? So now we can work using this view. Let me go out. I mean, I'll save these objects definitely, but let me tell you something. Before even we go to Scriptmaster, if you draw any objects, right, any view in nanoCAD Mechanica to create library objects, you should test the model, right? You should test the model to reduce to reduce the mistakes. If you are aware that how everything works, then you can straight away go to the Scriptmaster. And other than that, you should draw the objects, you should assign the variables, and then you should insert the insertion point from here, and then you should go to test model. So now if I go for test model, and now I selected the entire model including the dimensions, or rather I should say variables, and then hit enter, and this message, you should see the sketch has been successfully recognized. This is very important. You will have to find this message, otherwise the objects will not be identified by the Scriptmaster. So this is important. So for you, you will have to identify the objects even before you go for the Scriptmaster and create new. Okay, so now we'll go back to the Scriptmaster. So this is my objects. Now we were in the implementations, and now we will go to table. So initially implementation and then table, we will click on table, and here we will add tables, right? You don't need to name anything, the tables. What you need to do, this is very important, you should add some parameters, and you should type the exact same variables. So I created one variables called L, and the other variables is W, right? So this is the two variables I created, right? And you should type exactly the same, and you should right click on it and you can define the data type. I will choose real, that's fine, but you can choose integer as well if you need, right? So now I'll choose again, I need real, so both of the data is real, right? And now I'm ready. Now you can see the table, and maybe now you need to define how many variety you need to create that objects. So now you can say that I need maybe something 3 different types of objects to create. So now you can see L and W is here. So what is L? L is for length, right? And this is important. You need to write it properly, because this information will be available on the dialog box for the user to view and take decision. And then you should write width. So WI. So this is my width and this is my length, right? So now I should decide these two variables values. You can have different other variables depending upon the situations. You can make relations between different views, but here we are dealing with one single views. So here now we can say that I want to keep the length initially something 400. I want to keep the length something 400, and then I want to make something 200, right? And then I can change the number of digits after decimal sign that we can define in the settings, but for now this is okay. And now I'm saying that I want to make it something really big, 750, and I'll make something something around 500.25 to verify some tricky data. And we can say I'll make one more something like 300, and it is something 50% down, so 150. So this is the informations I will use. So these are different types of rectangle or some of the plates you can create this way. And then you should click on the description. If you these are for the BOQ, bill of materials, you can use these informations, but for now I will skip, and I'll say one more options here in the Make wizard, that is you can right click and you can define the preview. So you will have to create the 3D preview, or even the image will be okay. So if that image or the 3D preview is available, you can add those image or 3D model here for the preview. But for now I'm not going to add preview. Later on when we will be working with some legitimate objects, we will be using the preview, but for now we will use only the table and the variables, and that's all. So now we should go to, I mean, first of all I should save. So things are saved now, and further I will have to go to master in the Make wizard, and I'll use Scriptmaster, and here I will have to type something for the description. These are all for BOQ, so I can type something rec for plate or something. It doesn't make any sense, but that's fine. I mean, I can write anything, any of description you can write for the BOQ, and that's all. And then you will hover through all of these options. So I'll click next, and now this is very important, and you will have to decide what are the variables will be available for user to view on the dialog box, right? So for instance, if we use L, so now these are some of the decisions you will have to choose. We will talk a lot about these options, but for now you can say available for edit. This variable, which is length, will be available for edit where it will be on the dialog box, and it will be available for edit to whom? To the users, right? So this is how you can relate. And and the and the initial value, you can take either any of this value, the initial value, and that will be the default, right? So first time if you do not choose anything, that default objects will be created. So for now you can start with the first one or any of these of dimensions. So I'll take 400, the first one, so 400, and again I'll go to this W. So this is width, and this is also will be available for edit, and I will say, because I said length is 400, so I should say that if length is 400, then width must be 200. So this is the initial value. If we choose 400 for length, then we will have to choose 200 for the width, right? So I choose this, and I will not do anything with versions. Versions will be there, but that will not be used on the user dialog box, but that will be there, right? So I'll only deal with length and width on the dialog box, and then I'll click OK, Go to the next. I will not discuss anything here about parameter for the calculations because this is simple objects. So, but we can definitely make these options also available on the dialog box. But for now, I will skip and I will say next. And drawing conditions. This is for the complex objects. We'll create some of the switch, and I'll also discuss this, how to create switch and what is the benefit of creating switch later on. But for now, I'll skip this. And this is even more very smart options to working with different planes. If we are working with some of the complex objects, then we can use it. But for now, we will skip this. And same as for show height parameters, I'll turn everything on because I want to see these options. So these options will be turned on. These options will be turned on. So I'll click next, and it says that display conditions. This is also I can skip, but I can choose this too. I don't have any conditions for now, but I can choose this. And then check boxes. I don't need to be, but I'm checking this, all of these options. That's fine. I'll discuss later on what these options for. So we'll discuss later on, and then I'll say script. And this is, do not forget to save it. And I'll say yes, I want to save it, and I'll say okay, right? And now you can see the asterisk signs the moment you say save. So now things are saved, right? So one object's rect 0001 should be here. Once you refresh, it will be here. So this is the objects, right? I created this one. Maybe I'll save it. Okay, so now you can see as we were creating. For now, you can avoid this, but you can see that rect 0001 is here, and we have length and width. Initial value is 400 and 200, and we have properties. Currently, we have one single view, so we can only view one. In the future videos where we will be adding more views to show you how it works, so then we will find many more here in the view section. But for now, if we go to this, so it is 400 by 200. We can hover between this size. Can you see, if we click on the length, the corresponding width will be shown here. So now, if in case if we need to create the length is 750, the width will be 525. So I'll click OK, and I say OK. So it is now bigger than before. So now we should go to annotations, and we want to dimension this, want to measure this, want to see the value, right? So it will be 500 to 5. So as you can see, it's a 502.25. So this is very good. And this is 750, right? So this is very, very good. Now, as I said, that any point of time, if we create any view, and suddenly if you need to create one more, you just go to this and then add a value, number of rows 1, and I say that it should be something 250 by say 250, say square, right? So I'll say save. I'll say save, and that's fine. And that's all. That's what I need to do. And then I'll double click on this, and I should be able to find 250, right? So 250 by 250. So I'll click OK, and the dimension will also follow the objects because this is a smart objects. 250 and 250, right? So this is how it works. So I mean, now you can right click in this, and you can import, export these objects to send to anyone else who wants to use the objects. So this is a basic of creating objects, custom objects in nanoCAD Mechanica using Make Wizard. In the future videos, we will discuss some of the complex objects, how to create those those items I mean using nanoCAD Mechanica make wizard options, right? So there we'll find many more functions on this. Thank you. Keep watching videos related to nanoCAD Mechanica. Thank